Hello and welcome to York Universe, the astronomy and astrophysics radio podcast written and presented by students, faculty, alumni, and friends of York University. You'll find us now wherever podcasts are distributed. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by Paul Mackin. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. York Universe Radio podcast broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning 2 a.m. UT, if that's more your speed. We do run live on YouTube with the York U Observatory account and our online public viewing team. And if it's clear, of course, we show images live from the telescopes. To navigate to the live show or to find out more, check out our website, yorku.ca/science/observatory, and follow the links to OPV online public viewing. And you can join the live chat on YouTube. And of course, for the recordings of audio, you can find us wherever you get your podcasts. For questions, comments, and of course, any kinds of suggestions for future topics, please email us at observe@yorku.ca. You can also find us on Instagram, Facebook, and PixelFed for all the social media, Allan Carswell Obs or York U Observatory. All of our programs are free, including this one, but if you'd like to make a donation, you can see that same website before yorku.ca/science/observatory. Our amazing crew is monitoring the chat room for questions, but the current weather is really, really terrible. I'm actually getting snow flurries, and it is far too cloudy to open up the telescopes. How's the weather where you are, Paul? Let's just see if we can get our co-host here. Um, Testing 1, 2, 3. Do we have a Paul? All right, we'll go ahead and keep going with the broadcast, and hopefully our co-host is able to join in a little bit later.
We had a technical glitch.
Oh, you're
Sorry, I
here.
apologize. I am, yes. There's too many ways to set mute on the systems, I think. But anyway, yes, the weather where I am is disastrous, and but it's February, it's Canada. There's snow, and it's about what you'd expect. But we're going to talk about cold places tonight, aren't we, Dr. Hyde?
Indeed, we are, and we're talking about, of course, snow here on Earth. Snow and ice and wind. Most of that is, of course, water ice and snow from water. And of course, that's not the case throughout the whole solar system, which is one of the reasons why it's so fun to think about some of the icy outer realms. And this gets us right up to our first This Week in Space and Astronomy History, which is all yours, Paul.
Thank you. Yeah, so um, we're going to start off by coming back to the planet with the unfortunate name. Whenever I mentioned my interest in astronomy to a business partner I had years ago, he'd make a joke about there being a ring around. Well, I prefer to think of the name Georgium Sidus, but particularly when I'm dealing with droll business partners, or at least business partners who attempted to be comical. I suppose there will always be jokes, and yes, Uranus has several rings around it. In any case, this week in history, on February 16th, 1948, the natural satellite Uranus 5 was later christened Miranda, was discovered by Gerald Kuiper. Miranda's relatively small, with a diameter of 480 kilometers, and after imaging in 1986 by the remarkable Voyager 2 spacecraft, it was shown to be primarily spherical, which may make it the smallest object in the solar system to achieve hydrostatic equilibrium. And I'll explain what that is. When an object gets massive enough, it is forced by gravity and its mass to a spherical shape. Now, Miranda, I say, is primarily spherical because if you take a look at it, at the image, it's pretty tortured. Not quite spherical, but close. It has some large grooved areas, massive impact craters and canyons, and it is clearly misshapen. It's kind of what you'd expect from a transitional object between one big enough to exhibit hydrostatic equilibrium and one that's not. Now, of course, Miranda is very cold, very far away, very cold, very small. So the few Voyager images we have are likely all we're going to get until we get a mission to Uranus. And there is one under consideration by NASA with the working name of Uranus Orbiter and Probe, UOP. One hopes they come up with something better. This mission, though, if approved, wouldn't likely achieve any science objectives until the early 2040s. So we have to wait a while for better images of Miranda. Now, one thing of note, though, Gerald Kuiper went on to fame within the planetary astronomy community for his work on the outer solar system and postulated the Kuiper belt, which has since been confirmed and has even been visited by spacecraft. It's a massive volume of space outside of Neptune's orbit, home to hundreds of thousands of objects larger than 100 kilometers in diameter and trillions of cometary objects. So that's, the story of the first story of our astronomy and history this week, Dr. Hyde.
1948, great stuff. And of course, these early discoveries were they did not have a lot of details, initially present. And Miranda is one of the objects that we still don't really know tremendously large amounts about. I love some of the descriptions, though. The smallest large moon.
It
um,
is,
uh,
yeah, it's a weird looking place. You know
and
what?
it is.
It looks like something out of science fiction. It honestly does.
Yeah, and it's circular-ish. And if you ever wanted to see what a patchwork moon might look like, is if you had actually taken sort of quilt patches and tried to stitch a moon together. That's probably the best description I could come up with for Miranda. And we think it's got some kind of rocky core with a mantle of ice, and it's probably got, maybe several different kinds of ice out on its surface. We don't know enough about it because we haven't really been there. But it is interesting that out at this distance, you're well past what's called the ice line in the solar system, where water is water and or water is a solid. So as you go out past Earth, you get out past Earth and then towards Mars, there becomes a sort of a point where the sun is no longer powerful enough to evaporate ice, and so ice stays as a solid. And as you go farther and farther out, it gets colder and colder, and ice, water ice, actually gets basically more and more like a solid. And other things that we think of as gases, like carbon dioxide and nitrogen, can become ices and solids out at these incredibly cold distances. So you see things like icy valleys and craters and ridges, and you might think about, hiking in Canadian North, and you've got your ice pick and you could hike up it, but this ice would be very, very different as from what we see here, and not just because it's colder. So we can have some pretty exotic compounds out there, and this is a great object to start with.
I remember when the Cassini probe, uh, the Huygens probe landed on Titan as part of the Cassini mission. There were some stones on the sort of bed of whatever surface that it landed on, and they looked like regular rocks, but they were actually as hard as rock, but ice, like water ice.
Exactly. And that's, I mean, you have icy things all over, and especially ices that behave in extremely compact solid forms can have some really cool properties. But we'll leave that to the physicists for now, and maybe continue on to some more cold objects, actually. So I've got the next one, which is not as far back as yours. This is only 2004. But 17th of Feb, which is cheating just a tiny, tiny bit, 17th of Feb, 2004, a very interesting discovery was made. Orcus was discovered by the astronomers Michael Brown, Chad Trujillo, and David Rabinowitz on 17th of February 2004. And Orcus is a minor planet. And this is, we're going to talk about we'll talk about the most famous minor planet next, so I won't spoil too much. But it is things that are large-ish and a lot like Pluto. So Orcus has a couple of different names, but it is in the Kuiper belt of course, Kuiper fame, as you say. And it itself has a large moon called Vanth. So Orcus, the dwarf planet, is talk about icy. This one is really, really out there. And this small object is one of many that have been discovered since the early 2000s. More and more icy outer solar system things that kind of resemble planets, but also kind of don't. And until they're officially classified, they get called Kuiper belt objects or trans-Neptunian objects, depending on their orbit. Orcus is a large object that was actually spotted in the neighborhood of Pluto about around abouts of a decade ago, and 2 decades ago now, I think. And it has some size and orbital characteristics that are similar to Pluto, but it kind of has some opposites in as well. So um, Orcus is a dwarf planet, and it meets the criteria. So it is a pretty interesting one, in the sense that, of course, it could be one of many, many, being a smaller object and, of course, colder. It is hard to find, not being very able to reflect very much light due to its large distance from the sun. It has an orbit that goes around not quite circular like Earth's, but very eccentric. So it has kind of what we would call like an oval shape to its orbit. So it gets closer to the sun and then farther away from the sun. And it goes from about 30 AU, which is 1 AU is the distance from the Earth to the sun. So it goes from being about 30 times as far away from the sun as Earth to being 48 times as far away. So that's definitely not a circular orbit. And it is, as I say, quite out there. And the naming, of course, follows kind of the International Astronomical Union's standard naming. They tend to use, Roman gods, and this was one of the gods of the underworld. So Pluto was, I think, the ruler, and Orcus was a punisher of the condemned. So it doesn't make you really want to go visit this planet, or I should say dwarf planet. But the orbit and the rotation would make it pretty darn hard to get to anyways, because it's orbiting sort of up and outside of the plane of the solar system. So all of our regular planets kind of lie in a line around the ecliptic. We all sort of orbit in the same plane, but Orcus, like Pluto, is a bit different. So they're not quite sure how far what its rotation is, but it's in a 2 to 3 orbital resonance with Neptune, and has a period of 245 years. So it takes 245 years for it to actually go all the way around the sun, based in its current position. And over about 14,000 years, Orcus stays more than 18 AU away from Neptune. So that it always is a pretty good distance away from Neptune. So this is not one that's ever going to have any danger of colliding with Neptune or being captured by Neptune, as some things can. Orcus is sometimes described as the anti-Pluto, just because of its orbit being a bit opposite, which is a bit fun. And of course, having many different icy outer solar system objects, this one is really, really cold as well. We think that it might have a chance for what's called cryovolcanism, where water actually acts more like lava. So you'd have some amounts of water possibly being pressurized under the surface, and then you would have some sort of cryo cold water volcanism, which actually could be one way that not just Orcus, but other kinds of really icy objects like Miranda are actually renewing their surface. So why are we not seeing all of these things just covered and covered and covered in craters? Well, we talked about how odd Miranda was. Orcus, we don't actually know what its surface looks like because we've never gotten close enough to really get a good picture. The best picture we have is from Hubble, which is just like a blob of pixels being orbited by a much smaller blob of pixels. So we don't actually know what the surface of this one might look like, but if it is experiencing any kind of resurfacing or refreshing, it's probably using water as kind of a volcanic process with crystalline water ice sort of being blasted out or coming up to the surface. The moon Vanth was discovered a little bit later than the actual planet. This was in 2005, and it's if you get access at all to some of the Hubble data, they have some nice little free movies you can watch where Vanth is going around Orcus. And like Charon and Pluto, Vanth is actually quite large compared to Orcus. Um, so Vanth is the third largest known dwarf planet moon after Charon and Dysomnia. And the ratio is a bit uncertain. They're actually not totally sure how much each of them weighs or has the mass. But if we ever do get another satellite flying out into the icy outer solar system, this would make a pretty fun target, I think. What do you think, Paul?
Yeah, it's interesting. As you were describing its sort of orbital parameters and stuff, it makes sense that it would be the anti-Pluto. It's it goes it goes almost as close to the sun as Pluto and slightly further away from the sun as Pluto. Its orbital period is within 3 years of Pluto's orbital period. Um, and we don't have a lot of data. We've got I guess if you consider Karen to be a Kuiper Belt object as well, and I suppose you could. We have 2 data points from about 3 data points. We'll talk about those later, but it would be a fascinating place. I mean, it's the biggest piece of real estate in out there. It's huge, and it would be there's so much material out there. It'd be amazing to explore it.
Absolutely. And speaking of things that are amazing to explore, um, that should get us to your object.
So, slightly more than 1 week from today, on February 18th, 1930, the planet Pluto was discovered. And this was at the tail end of a bit of a detective story that starts with the discovery of the planet mentioned earlier, Georgium Sidis, back on the 13th of March in 1781. When Herschel found Uranus, which was the eventual name given to Georgium Sidis, its orbit was plotted. Something didn't make sense. Another body appeared to be tugging on Uranus, perturbing its orbit, which led to a search for another object further out in the solar system. That search culminated with the first observation of Neptune on the evening of September 23rd and 24th, 1846. So 60 odd years later, 55, 60 years, I guess 65 years later. As time went on, though, Neptune's orbit also didn't quite make sense. So they began a search for a planet even further out. And this hypothetical planet was called Planet X. So now we're going to skip forward to 1906, and there was an American businessman named Percival Lowell, and he began searching for Planet X. Lowell was very interested, perhaps even obsessed with planetary astronomy. He's most famous for his work on Mars canals. He mapped out the most complex, the drawings are beautiful, the most complex system of canals on the surface of Mars, and postulated that these were signs of intelligent life on the planet. Many other astronomers also saw these artifacts, but there was a problem. They didn't actually exist, and they have since been attributed to a combination of optical illusion and wishful thinking. Detailed explorations of Mars began in the 1960s and shows Mars to be barren, dry, nearly airless, and indeed no signs of intelligent life there at all. Now, Lowell made several observations of Uranus and Neptune and had people calculate, they were called human computers, people calculate to try and determine where planet X might be. And many years after his death, a young astronomer named Clyde Tombaugh, working at the Lowell Observatory, detected a planet near
For one
where
minute. Paul, we lost you there for a second. You were just
my
saying about the young astronomer.
okay. So the young astronomer, can you hear me now?
Yes, we can hear you now.
I don't know what happened there. Okay, the young astronomer named Clyde Tombaugh, working at the Lowell Observatory, detected a planet near where Lowell's team indicated it should be. The planet was named Pluto, and a symbol for Pluto is a P merged with an L, which many attributed as consider a tribute to Lowell. Now, from here, the story starts to get muddled. For a planet to perturb the orbit of two large objects like Uranus and Neptune, it has to be massive. Pluto was very faint and far away, but it seemed to be relatively small. And in 1978, Pluto was discovered to have a moon, which was later named Charon. And that and given that's orbital period, we were able to work out the mass of Pluto, which was found to be much smaller than expected. Um, it began to seem really almost impossible. In fact, it was impossible that this could cause the discrepancies in the orbit for the calculated for the orbit of the other two planets. Further, when the Voyager 2 spacecraft, which we mentioned earlier, which is a fantastic little robot, flew past Neptune in 1989, it discovered that Neptune's mass was not as calculated. And that put the orbital issues of Neptune and Uranus to bed after more than 2 centuries. As I said, Pluto's size is much smaller than expected. In fact, it's less than 1,200 kilometers in diameter and would easily fit inside Canada if you laid it on top. It's big enough to be spherical, but not big enough to clear the debris out of its orbit. And in 2006, the International Astronomical Union decided to redefine what planets were, and Pluto was demoted to a dwarf planet. But that same year, the New Horizons spacecraft, which is very small as such things go, was placed on a huge rocket and sent as fast as possible on a flyby mission to Pluto. Planet or not, it has been explored and was discovered to be a complex and fascinating world. And this final bit makes me very happy. On board the New Horizons spacecraft was a small vial of Clyde Tombaugh's ashes. He died in 1997 at 90, but part of him will always be journeying out of our solar system and into the void beyond.
That is very wonderful, and of course, one of the very first to get their ashes out into the solar system, and by far, I think the farthest that anyone's ever gone. So, huge congratulations to whoever made that happen. And of course, as
Yeah,
you say, Pluto is such a wonderful, wonderful, interesting place to investigate, and we have beautiful, beautiful pictures of it.
and of course, with Valentine's Day this week, Pluto has a heart. It has a big, flattish area on its surface that's heart-shaped, and
Yeah.
so that makes for a great Valentine's tale, I think. You can get a picture from Wikipedia or whatever source you want, long as you attribute it and you can print it up and give it to your sweetheart for Valentine's Day and say, I'm not just giving you a heart for Valentine's Day, I'm giving you a planet.
Yeah, it was quite interesting to see the first images come back, and of course, the side of Pluto that got the flyby had the little heart on it, and a bunch of astronomers were kind of like, "Oh, we shouldn't have demoted it. Look, it loves us." So a lot of people have had lots of fun with Pluto's heart, but I will just call out the really unusual cold chemistry on Pluto as well, because it's not all just fun and games. The structures of the ices on Pluto are really amazing. We know that there's snow on Earth, but the snow on Pluto is not like Earth's. It's frozen methane, not frozen water. The methane, the gas, has gotten so cold, it's frozen and become uh, snow. So it's actually managed to fall and actually snow on Pluto. Pluto has a really tenuous atmosphere. It is very far from the sun. It's extremely cold. And on Earth, we know that we have sort of an atmosphere where temperatures can rise and we create little circulation bubbles. And of course, we have mountains where the air, as the air descends, gets warmer. But on Pluto, it's a whole different ball game. They have only at the tops of the mountains is there enough methane to form the snow, and Pluto's thin atmosphere is mostly just nitrogen with trace amounts of carbon monoxide. And it is really interesting to look at some of the structures on Pluto because they do almost look a little Earth-like, but the chemistry behind it is totally different. Um, the methane can absorb sometimes heat, but it doesn't just have methane as snow, it has nitrogen ices on its surface. And there's a really nice area, I believe it's called the Cthulhu Plateau or the Cthulhu region on Pluto, where because Pluto's atmosphere is so thin, it can't actually heat the planet's surface. So when there's, it becomes extremely cold, and you almost get kind of an inverse, sort of snow formation. It's totally different than on Earth because it's not depositing moisture as snow on mountains but because of warmth. And Pluto, it's like a totally inverted thing. And I just thought it was so interesting that it could look so similar, but have a such totally different chemistry and physics behind it. The methane concentrates at higher altitudes because of the way Pluto's atmosphere circulates, and it's almost a sublimation effect. Um, and it's really interesting. So if anyone has a secret love of utterly bizarre chemistry, this is definitely one to go and look for because Pluto, we have actually flown by, and there was some really good data from New Horizons.
And one of my favorite pictures to talk about the weird chemistry, and bear in mind, you're sitting out at a place really far away. It's very cold, and then the New Horizons was leaving the Pluto system, turned around and took a picture of the atmosphere, with the planet from behind the planet. So the planet was in darkness, and lo and behold, Pluto has a blue atmosphere. It's probably got a blue sky if you're standing on the surface. And one of the other things I found really cool was that around the time this was going on, NASA had a website up where you could type in your location and it would tell you what time at night in the early evening or early morning to go outside, and that would be the same light intensity. It'd be as bright as it would be at noon on Pluto. And, it was kind of late dusk. It wasn't very bright. It wasn't very bright at
Yeah,
all.
exactly. And that's because, you're middle of the day in Pluto, your sun at that distance is going to be just really a bright star. You would be able to see almost all the stars in the sky in the middle of the day because the sunlight is so dim there. It would just be a very strange, very, very strange place to be looking out of. Anyways, lots of fun. And we have, looks like, one more icy object to discuss. So I'm going to take us, again, a little more recent to something a little bit more esoteric, I should say, a little bit harder to find. February 14th, Valentine's Day. So a Valentine's discovery talking about hearts in space in 2006. So, oh my gosh, I can't believe it. That's almost 20 years ago now, but holy moly, time flies. Um, 2006, Valentine's Day, there was a very interesting discovery of a um, trans-Neptunian dwarf planet called Quaoar. And this is a hard one to pronounce because it has uh, a lot of vowels. It's a Quaoar. And Quaoar is natural satellite WAWAT was officially discovered on Valentine's Day. So make sure I say that right. It was the WAWAT satellite that actually gets discovered. So it was basically on Valentine's in 2006, they found out that this icy cold trans-Neptunian dwarf planet wasn't alone after all. So it was like, oh, that's nice. It was discovered by Michael Brown and Terry Ann Sewer using images taken by the Hubble Space Telescope. So Hubble to the rescue once again. And these objects are also very, very, very cold. So you have, again, very strange chemistry happening on them. But we have never gotten particularly close to either one of them. So we don't have great pictures of their surface. We just have Hubble Space Telescope, which cannot quite really resolve anything. It's a blurry circle with a much smaller blurry circle next to it. So WAWAT, which is also sometimes really confusingly called Quaoar-1, which it should just have its own name. This is thought to be possibly a fragment of the Quaoar dwarf planet that was maybe fragmented off through some impact event. So maybe something hit it and a big chunk flew off and now it's a moon. And if that sounds familiar, we think that also might have happened to Earth in a little bit of a different way quite some time ago. So it's only 200 kilometers or 120 miles in diameter. So it's a pretty small object as far as moons go, and it's probably very irregular shaped. We can't really tell. Um, but it orbits Quaoar at every 12.4 days, so not once a month like we have. It's a pretty fast little moon. And we think that it actually helps maintain a really interesting discovery, which is uh, Quaoar's ring. And Quaoar has a really interesting structure around it in this sort of ring around the planet. So this is part of the evidence, I suppose, for it being a collision, because there's a debris field around Quaoar. The presence of a ring is kind of like, why has this material not dissolved or collapsed into the planet, or why is it still here? It's not, we don't see a active collision debris. It's a nice contained ring. Well, the moon might actually be helping keep it in check. Um, So it's a pretty interesting little moon and a pretty interesting system. Just as a little tie-in, the Quaoar itself is also in the Kuiper belt, like so many of the objects we've talked about tonight. It's in this whole region of icy planetesimals out beyond Neptune, and it has not quite a circular shape, so it seems to be ellipsoidal from what they could tell from the Hubble Space Telescope images, and it's only about half the size of the dwarf planet Pluto. So we talked about how Pluto was very small and hard to detect. Well, the reason this one took so much longer to find is that it's actually smaller, about half of the size. And it does seem to have water ice and ammonia hydrate, which means that this might also have some cryovolcanism resurfacing its surface. If only we could get there and send a satellite to go and look closely so we can get beautiful pictures of it. But yes, they were able to detect it with a very, very popular detection technique that's been used from everybody since we had photographic plates on up. These blink imaging, where you take an image of the sky, you take another image, and you look for something that's moving with respect to the background stars. And so if you want to see the discovery images of Quaoar, they actually do have little GIFs out where you can see a nice field of stars and it sort of blinks a little bit and there's one little dot that seems to move. And this is how we can find all kinds of things. We can find near Earth asteroids and satellites because they move with respect to the background stars. The background stars just, sit there and appear to move at the distance that the Earth turns. And this was also actually part of the search for the hypothesized planet X. And there's still a lot of discussion out there about what would the biggest object be that could still be out there in the icy outer solar system that we couldn't have found by now. And so as we go out past into the Kuiper belt, out past Pluto, we start finding that there seem to be other large objects Pluto-sized or nearly Pluto-sized or half Pluto-sized. So one of the fun games that astronomers like to play when thinking about these is, well, the farther out you go, the larger your object could be before and still be hard to detect. So in theory, what could we have that would be out that far that wouldn't be a gravitational perturbance and would fit with all of our models? And you know, what could be out there if it's such a fun game to play. So if you like modeling, it's a lot of fun. And if you like icy outer solar system objects, we have only scratched the tiny surface of this particular mountain to climb.
It's really quite fascinating, and it's going to tie into something we're going to talk about in a bit. What is out there, but I think maybe it's time for our reminders, and then we can get on to Astro News.
Absolutely, it is in fact time for reminders. But first, I have to go ahead and do the main reminder, which is everyone, you're listening to York Universe, broadcasting live from Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Our website is yorku.ca/science/observatory. You can find out about all of our other programs, our totally free, amazing Wednesday night in-person tours, and more. Tonight, you're listening to Paul Mackin and Dr. Elena Hyde, and we are discussing cold things. So let's get back to it and get to our announcements. We do have a couple announcements, very important. So if you're listening to this anywhere near the week that we broadcast, please be aware that there is no podcast broadcast or OPV next week because, of course, it is Family Day in Ontario and this is an official holiday and all of our students will be gone. So February 17th, there will in fact not be a York Universe, but we'll make up for it by being one episode closer to the fabulous 600th episode, which is coming up soon. Also in the reminders, the Allan Carswell Observatory would like to send a huge thanks out to Ontario Downsview Park in Toronto. They were hosts for our wonderful Hearts from the Sky Valentine's Star event this last weekend. Also a free event. So if folks are planning on looking uppity and seeing not necessarily hearts in the sky, but celestial objects that have beautiful hearts on them. Pluto is very hard to see and in the wrong part of the sky, but you can see the moon and Mars, both of which have beautiful heart-shaped craters on them. You won't be able to see the heart-shaped craters, but you can find it where they are, and you will be able to see the moon and Mars if you have clear skies. So that's our reminders for this week. Of course, we do have a Wednesday tour coming up for our regular Wednesday public viewing. So if you want to find those free tickets, that's on that same website I keep giving everyone all broadcast. So let's get into some astro news, Paul.
Great idea.
There's so many great stories out there at the moment. We are spoiled for choice, but I figured maybe we'll start with your one first.
Okay, fair enough. So back to Pluto. Uh,
Yay!
it's devotion. I mean, if it's going to be cold here, we may as well share the joy. But Pluto's demotion back in 2006 was a bit of a stir, but it made a lot of sense. Pluto is tiny as planets go and doesn't really meet numerous criteria for what a planet is. And like the main belt asteroid, it's really far, Ceres, it's far better designated as a minor planet. Still, Pluto may also be something completely different. And in 1992, the first specific Kuiper Belt object, Albion, was discovered. It's about 100, it's a regular shape, so it's about 167 by 108 kilometers in size. It has more of a circular orbit than Pluto, and it takes slightly longer to go around the sun at 291 years as opposed to Pluto's 248. Now, Albion's discovery was the first of many. The count is over 2,000 objects in the Kuiper Belt, but there may be as many as 100,000 objects of Albion size or bigger, objects bigger than 100 kilometers. Some may be the same size as Pluto itself. While I wouldn't, describe Pluto as commonplace, it's undoubtedly less rare than we once thought. So after some time, the orbits of these planets, or of dwarf planets, were calculated, and something familiar cropped up. The orbits seem to be connected to something in the outer solar system, something quite massive. Their orbits seem to resonate with this point in space. So two researchers from Caltech, Konstantin Batwagin and Mike Brown. Mike Brown, Dr. Hyde mentioned earlier, was a discoverer of one of the Kuiper Belt objects, have hypothesized that a planet with a mass of between 3 and 5 times that of the Earth is orbiting somewhere, out 5 to 10 times that of Pluto, with an orbital period of 10 to 20,000 years. It is really far out there. Okay. This object would be tough to find. It's really, really dark that far out. While
Oh
estimates
yeah.
of, while estimates of its magnitude would be in the range of what our telescopes can detect, you have to know precisely where to look, or you have to look at a lot of places over a very long time. Maybe you could look at the whole sky 825 times over 10 years or so. And that just happens to be the exact characteristic of the primary mission of the Vera C. Rubin telescope, which we discussed last week in our podcast. Again, Rubin has a task of capturing very detailed images of the entire sky above it every 3 days, and that data would be consumable for computer algorithms looking for Planet 9 and other trans-Neptunian or Kuiper Belt objects. So far, Planet Nine has eluded us, but many scientists feel that the hypothesis itself for Planet Nine is very credible. So, could we visit, you know, this planet or other objects in the Kuiper Belt? Well, on January 1st, 2019, 3.5 years after visiting Pluto, the New Horizons spacecraft, with its passenger of part of Clyde Tombaugh, was flying on an extended mission, and it flew past the Kuiper Belt object Arcoth, and I think I pronounced that right, which was discovered after New Horizons was launched. It passed just over 3,000 kilometers away from this really strange looking space rock, which is 40 kilometers by 20 kilometers by 9 kilometers, which makes it look like a reddish, dusty snowman, which is flat on one side. And the spacecraft was traveling at 14.3 kilometers per second, really fast. So it didn't have a lot of time to look at Arcoith, but it sent back pictures and they were remarkable. And you can again look these up.
Oh yeah, those are great
Just
pictures.
incredible. Yeah.
And I have to say that it does have a nickname of Space Duck because it looks a lot like a rubber ducky.
It does. That's a good. I actually think it reminded me when I was a kid, we had these inflatable snowman balloons that you could use as punching bags. And it reminded me a little bit of that too. But I like the duck one better. It does look, and the colors kind of goes in that direction. It's quite red. But getting to Planet Nine, if it exists, and roughly where I think it is, it would probably take about 20 years if we leverage some innovative techniques such as a powered slingshot around the sun, something called an Oberth maneuver, which has never been attempted for this kind of mission before. But Planet Nine, again, if it exists, it's likely discoverable and visitable by technology we have available today. So, I just say that we live in exciting times, and that's great. What do you think, Dr. Hyde?
Oh yeah, I think it's great fun. And of course, the as you go farther out, it's really hard to even picture the incredible vastness of the not anything that is out there in between all the stuff we want to try to find. And the farther you go, the harder it is to get any kind of reflection off of a planet because the sunlight has gotten so dim by that point, and it has to travel and bounce off the planet and come all the way back to us. Because most of these icy outer solar system objects, Pluto, Arrokoth, they don't emit any light. They can only reflect what our sun has sent to them, which is going to be so small. And it is really interesting to think about, well, if we do have an Earth-sized planet or a multi-Earth-sized planet out there in the icy outer solar system, this would be really interesting for one of my other favorite kind of things to think about is, well, as you get farther away from the sun, the gravity of the sun also decreases and your chances of becoming unbound increased. And this is how we think that something like rogue planets can occur. And in our own galaxy, one of the great questions that we haven't really been able to answer is how many rogue planets do we think are wandering around without any star at all? And those are also going to be, well, at least the large ones are going to be things that the Vera C. Rubin telescope can help us find. And if it ends up being more than we thought, um, this is going to really affect a lot of our modeling. And it's just a cool idea because, of course, I saw that Star Trek episode, Rogue Planets, running around. And because we can have, room for these unexplained areas of the solar system, it just gives us So much to think about. And if you're watching the news, like oh, I don't know, this morning, you might have heard everyone getting really, really excited about one of our other space news items, asteroids, which come from, well, some of them come from the asteroid belt, some of them come from the icy outer solar system, some of them come from having too much stuff evaporated off and starting as a comet and then being an asteroid. But asteroids are very, very big news for Earth because they're also incredibly small and they tend to be kind of dark and dusty and not reflect very much light. So they're also really, really hard to find. And watching for asteroids is just as difficult as trying to find trans-Neptunian objects, maybe even more so in some cases. So having things like good asteroid detection, this is pretty relevant for us here on Earth because the larger the asteroid, the bigger the dent it's going to make if it does crash into us. And was it last year or the year before that? We had that wonderful bolide fly over Toronto, and it was beautiful and made a great show and landed in the lake, and it was amazing. A few extra thousand times of size, and it starts to become less of a nice show and more of a hazard. So we always want to find the likelihood of impacts, and there has been an asteroid that has kind of caught everyone's attention. This is called it's got a terrible name. It's called 2024 YR4, and it has a and they've actually increased it. They said it had a 1.2% chance of hitting Earth, and now they're saying it has a 2.2% chance of hitting Earth. So the near-Earth asteroid 2024 YR4, it's a very low probability that it is going to come into contact with Earth, but it was increased to a 2.3% chance on December 22nd. It was increased to a 2.3% chance that it will hit on December 22nd, but not until 2032. So as ground-based telescopes keep watching this asteroid, and there is an international asteroid warning network, just so you know, we can keep a track of it. They'll continue watching it while the asteroid is still visible through April, and they'll keep making adjustments to their predictions as they gather more data. So after it disappears in April, it will actually be too faint for any of our telescopes to observe until 2028. And that's actually a lot closer to 2032. So maybe we'll hope that they don't revise it up. The James Webb Space Telescope will also observe this particular asteroid in March of 2025 to get a better idea of the size. Currently, we think that it's about 130 to 300 feet across, and I'm sorry I didn't convert that to meters. But as we get more information about the asteroid's orbit and its details, its impact probability will become better known. And it's possible that it will actually be ruled out as an impact hazard, as has happened with many, many, many other asteroids that have actually appeared previously on NASA's asteroid risk list, which is a thing you can look up and check yourselves if you are curious about which asteroids currently pose the highest risk of hitting Earth. This is actually maintained by NASA's Center for Near-Earth Object Studies, and they give updates on impact probability and all that good stuff. So it is pretty interesting times, and this you will have seen all kinds of clickbaity articles about, oh, new asteroid going to hit the Earth. It's a 2.3% chance. So that's a 0.02 three. It's a very small chance, and this is not there's the meters conversion, about 40 to 90 meters and 130 to 300 feet, because they don't have great measurements of it yet. They're not really sure exactly how big it will be. So it would be big enough to make quite a dent if it did impact, but not a dinosaur sort of event.
Yeah. Well,
Anyways,
I'm certainly not going to lose any sleep over this. And but one of the great I think it was Carl Sagan who said it, uh, is one difference between humans and dinosaurs is humans have a space program, uh, which may help us escape the thing that killed the dinosaurs. So that's a positive note on this. But people get nervous when they hear things like this, and it's important to, put this in perspective. Risk analysis is
yeah,
something that we all have to
exactly. And
be
it's
more comfortable
interesting.
with. Yeah,
And it's interesting to watch, and it's something that we can take a little comfort from as well, is that it wasn't that long ago we actually had a successful asteroid redirection test that was
we
DART.
we
Um,
did. We
the DART
did.
mission. It worked way more effectively than they thought it would. And so we humans actually have some pretty amazing things that we can bring into this asteroid discussion should it become necessary.
hmm And of course, we're going to know even more about how successful that was. I think late this year or early next, with the Hera mission, the ESA, European Space Agency, has launched a follow-up mission to DART that's going to fly by and actually rendezvous with the DART target asteroids, the moon and the main asteroid, and image it, which will be it will we'll get a much better feel for how much things changed and what impact, no pun intended, we actually had.
Yeah. Oh, you can have the fun. I'm a fan. And for those of you who are maybe not familiar with DART, this was an impact on an asteroid where we humans actually launched a craft and impacted the asteroid Dimorphos, which was the smaller of two asteroids going around each other. There was Didymos and Dimorphos, and we impacted the smaller one by just like slamming into it. An artificial projectile impacting an asteroid. It didn't have any advanced, there was no like that movie Deep Impact with the bombs, none of that. It's just a straight up, we're just hitting it with velocity. And it actually worked really, really well. So Hera going up to get better information will show us exactly how efficient it was and what by hitting it in the way that we did, what was the full effect of the orbit on Dimorphos and Didymos, and hopefully understanding a little bit more about this sort of what they call it is kinetic impactor method, but it really just means we hit it hard with something going fast.
Yeah, there's a number of different hypothetical ways to deflect an asteroid, but the kinetic impactor was the easiest to accomplish, I think, and as a first test, and it seemed to blow up real good. And Hera gets there. I thought it was this Christmas, but it's next Christmas. It's December 2026, but not that long to wait.
Yeah, that's and in the meantime, we do have, of course, JWST following up the 2024 YR4 asteroid and all kinds of other things. And actually, isn't Hera they're taking a stop by Mars as well.
They are the
Um,
Flying Hero by Mars. Yeah, it's got a it's doing a gravity assist, and it's going to be imaging as well.
yeah, and of course, Mars has two moons, Deimos and Phobos, which are very irregular in shape and very asteroidy looking. So having and actually not entirely stable, so they probably will crash into Mars at some point in the very, very distant future.
Yeah,
Um, but
Mars is specific. Mars is suspiciously close to the asteroid belt, and it's got two moons that look suspiciously like asteroids.
Yeah, and there's been a lot of speculation about those moons going back and forth, but they look an awful lot like asteroids. And oh my gosh, there's actually So we're pretty far away from April, but if you are looking up moons and Mars, just watch out because there are still stories going around that were perpetuated by an April Fool's hoax back in 1959. And one of the newspapers published about that the moons of Mars are artificial satellites, and so you actually can you can still see those stories if you end up searching for Martian moons today. So buyer beware, I suppose. And on that note, we Mars is very, very cold as well, and we have lots and lots to look forward to, despite the icy, chilly weather.
And spring is just over 6 weeks away. So I always say that February is a terrible month, but it goes by quickly.
And it gives us a chance to discuss all these wonderful icy objects. All right, so let's go ahead and end off for the evening. Everyone, you have been listening to York Universe, the astronomy and astrophysics program, written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Paul Mackin and myself, Dr. Elena Hyde. You can always connect with us, on Instagram at York U Observatory, Facebook at Allan I. Carswell Obs, and Pixel Fed over at Allan I. Carswell Observatory. We have show notes, content updates, free tickets, and more, all on yorku.ca/science/observatory. Thanks for tuning in to York Universe, everyone. Clear skies and have a good night.
Keep warm, everyone. Good night.